So I'm Dr. Mark Jackson. I'm the Senior Quantum Evangelist at Quantinuum. We are the largest quantum computing company in the world, and we focus on both hardware and software. And I think in the next coming years, we will look back at quantum computing as the major technology. I think this will probably be the most important thing discussed at this conference. So quantum computing will have huge ramifications in AI, chemistry, machine learning, and cybersecurity. And sometimes I talk to people and they think that it's sort of science fiction fantasy, that it might be relevant in 20 years. And I think people are shocked to discover many people expect that only in 1 to 2 years will we have practical applications of quantum computing. And so we're very excited to be talking with you today. So we have a very distinguished panel. So from left to right, we have Charles Beigbeder, the founding partner and chairman of Quantonation. We have Marcus Flitch, the founder, CEO, and chairman of Terra Quantum. And we have Manny Medina, chairman and CEO of Medina Capital Partners. So welcome very much.
Good morning.
So the format is that I've asked each of them to present 2 examples of what they think are the most important topics in quantum computing. And so we're going to go through and do this, and then perhaps we can open it up to questions from the audience. So Charles, would you like to go first?
Yeah, Mark, thank you for having me today. I'm very proud to be invited at this conference. So we are Quantonation. Quantonation is of French origin, but it's the largest fund in quantum technologies, a venture capital fund. It's a little bit crazy. That was 5 years ago. With Olivier Tonneau here and Christophe Jorsac, we founded this fund. And now we have like 25 portfolio companies only in quantum. And so quantum, in a nutshell, is the universe is discrete. so that means that you have immense reserve of information downwards at the atomic scale, and there are numerous applications. So quantum, first, we have plenty in our smartphone, lasers and transistors. That's first revolution, first quantum revolution. Then you have second quantum revolution, and that's what we are talking now. So it's entanglement, and therefore it's the application in cybersecurity to secure an exchange of information between point A and point B using a fundamental law of nature, and also, of course, quantum computing, optimization. So to answer your question, sorry for the introduction, and so I think I wanted to point out 2 applications. The first one is we talk a lot of quantum computing, of course, and quantum networks, but there is also quantum sensing. So sensing is the most mature application, by the way, is using the fundamental brick of this second quantum revolution called qubit. So it's an atom or a photon. A quantum, let's say, thing, individual, and it can be used. It's very fragile, very sensible to the environment. So it's a problem to make a quantum computer, but it's great to measure physical fields.
So a bad quantum computer is a good quantum sensor.
It's a fantastic sensor to measure, for instance, the gravitational field of Earth or the magnetic field of Earth, and there are firms, there are governments, agencies at the moment working to have a kind of digital twin of the Earth, of the globe, measuring very precisely, like 10 at the power of minus 10, the magnetic field and the gravitational field of Earth, in order to have this digital map, this global scan of the Earth, to navigate in case there is a conflict and the GPS, is no more available. So that's the future, but it's being done now. NASA is funding a project with Sandbox AQ, for instance, but there are other projects with SB Quantum in Canada and French firms as well, Quantinuum, in which we have invested. So it's just incredible as an application, and it's now. And those firms are making revenues, even profits. So it's not like science fiction. And the other example I wanted to quote maybe quickly is about quantum computing. So quantum computing, digital quantum computing, there are machines there, and I can mention maybe our investment in Pascal, and I'm very happy that Shema from Pascal has opened our Saudi branch. It's fantastic to be there, thank you. And because Aramco Ventures have invested in the company. So So you have digital application, of course, but it's progressing, and this is to optimize some very complex problems. But you can also use a network of qubits to simulate nature. That was the initial idea of Richard Feynman, by the way, in 1982. And so it's possible now. And the dream of any, you mentioned chemistry, of any chemist is to invent new materials, but it's fair to invent new molecules. We are always working with the same molecules for the last 3 centuries, but there are billions of potential molecules. How to identify the ones that are the most appropriate for chemistry, for some industry, for maybe transportation, energy. Well, the dream is to simulate all those molecules in silico on a computer. And so a quantum computer can analogically simulate all the molecules and then maybe find the molecules that will trigger a fantastic revolution, technological revolution.
So, thank you, Charles. Marcus?
The 2 things.
2 things.
Things. All right. Let's step one step back. Why are we sitting here? Why is quantum computing reviewed as so disruptive? Because the underlying technology will provide an exponential speed up in compute power. The exponential function sooner or later overtakes everything. That's why people are so excited about quantum. But you also might have heard the quantum hardware isn't yet there. So the quantum chips we have, they aren't really scalable yet, right? So it's a lot of R&D. And therefore, a lot of people think, well, there is still a few more years to go until we have some meaningful application in quantum. But that is only half of the truth. And my 2 things, actually, we are very much aligned, are in the context of quantum is now. What can we do with the technology already today? And not talk about science fiction. The first one is on the algorithm side, right? The algorithmic power of quantum computing is tremendous. So everything which has to do with big data analytics in optimization, simulation, machine learning will be blown away if it's complex enough by quantum algorithms. And they will run on future quantum chips. But we can bridge the gap until we have those mature quantum chips with something we call hybrid quantum computing. So we simulate the hardware on classical high-performance computers to create the platform to run the quantum software, which we can write today, and we do that today. And by doing so, we can unlock substantial potential already today. One example, in portfolio optimization for investment banks, we as Terra Quantum, we are a quantum as a service company, one of the world leaders in quantum software, we can save investment banks already a couple of $100 million per annum in recurring cost by just moving one classical algorithm into the quantum space. So that is tremendous. My second thing also is about cybersecurity. So every classical encryption code will be hacked by a future quantum machine. So therefore, bigger than Y2K, the whole world has to migrate to quantum secure communication protocols. And that is something which you have to fix before the quantum hardware is actually there, because the day the hardware is there, you'll be hacked. Therefore, we provide quantum security protocols, implement these over existing optical fiber infrastructure, and that is also a big migration movement right now already. So the most innovative companies, we, for instance, work for one of the largest corporates in the US, they already, secure their private networks with quantum secured protocols. Yeah.
Thank you, Marcus. Manny, and I hope you'll share your unique perspective, the thing we discussed, that you were there at the origin.
Yeah, absolutely, Mark. Thank you. First of all, I'm at a great disadvantage here among these elite physicists. As you know, I'm not a physicist. I'm an investor. But my name is Manny Medina. I have been investing, and our firm has been investing in our team in technology for over 30 years. So our goal is always to invest before the hype cycle, meaning before it becomes crazy and then you lose a significant amount of money. I have just 3 examples. I started in this when the internet, and basically, we were successful in building a company, investing in data centers and all that before the hype cycle, basically, and we built it, sold it for a couple of $1 billion to Verizon. Have done the same and try to stay ahead of the hype cycle. The next investment theory, it was when the hypervisor was invented. Basically, you had all this massive amount of computers with empty capacity that wasn't being used, and then some very bright scientists ended up inventing software that extracted that capacity from those computers and then created what is now called the cloud. We invested in the cloud way before, and as a matter of fact, if you see in 2011, the company that we sold at that time, they were the 2 leaders in cloud computing was AWS and Terramark, the company that I founded. A third example is cybersecurity, which I'll get to quantum in a minute. So cybersecurity, we began investing in cybersecurity. It wasn't even called cybersecurity, it was called InfoSec at the time. So we started, and cybersecurity at the very beginning was mainly very hardware-based. The whole principle of cyber is that you created a moat around your infrastructure, and basically nobody could get in. So kind of a castle and a moat approach. So what happened then was that as the hypervisor and the cloud came and mobility came, that perimeter that you tried to guard didn't exist anymore. The perimeter was everywhere. The perimeter was everywhere that your mobility is, etc. So the only way that you could guard your infrastructure is through software. So there was a whole shift away from hardware to software. And basically, we invested in a company called Appgate, which I'm still the executive chairman on. And that company became, even before Zero Trust, we became now the leaders in Zero Trust network access, right? Basically, as a matter of fact, a number of customers right here in the kingdom. So anyways, the reason Mark wanted me to say this, because my philosophy is that you try to beat kind of that hype cycle, and where does that bring us today, and what is my interest, or our team's interest in investing in quantum? So in a small world story, we have an event that we run in Miami every year, kind of like you have something similar here called LEAP. It's called Emerge America. For those of you from the States, it's kind of a little South by Southwest with a focus on Latin America, North America, and Europe. And our interest in quantum began...
What year was this, just for context?
2015.
2015.
So we began getting interested in quantum through the event. We used the event as a catalyst to really content, next generation technologies. These 3 folks are going to be there next year. So we began interested in quantum in the year 2014 or so.
And back then, very few people took quantum seriously. This was the very beginning.
But we have a team just kind of doing this. We have a lot of fun thinking about what's going to happen 15, 20 years from now, right? Basically. Yeah. And so we specifically chose quantum, and through luck, we chose Mark and I didn't know each other. I didn't even know that it was actually...
My boss, Ilyas Khan, the founder of the company, was there.
So he came to our event and actually talked about quantum when, wow, quantum is a really difficult subject. I admire these guys because they really understand it. I'm telling you. Even Einstein, he kept saying, scary.
Spooky action at a distance. Quantum entanglement.
It's really, really, really difficult to comprehend, right? So the founder of the company came, presented, and that was so my interest in quantum, at that time, I absolutely 100% was convinced that we were way too early. I admire my new friend Charles here to having begun investing already a number of years ago. So we held back. And all of these cycles of these technologies have certain things in common when you look at them, all of them. The internet, the cloud, the software, cyber, zero trust, etc. They all have to significantly reduce cost. They have to significantly augment productivity, and sometimes meet a mandated requirement by government, right, basically. And if you look at them, it's pretty eerily. So where do I think we are in quantum today? I think quantum is ripe, right this moment. As a matter of fact, we're very actively, have a team actively looking. We've analyzed a number of startups working on the hardware, and hardware advancement on the chip. We met with with a startup in London, basically that is developing a silicon-based chip instead of a metal-based chip, and so it's a so we feel that first of all, as all these changes that I've been fortunate and blessed to see, I believe that quantum is going to dwarf everything that I've seen and experienced. I believe quantum is going to change every aspect of our lives, and I 100% believe that in all these cycles, two things happen also. You have incredible disruption of companies that end up being in really bad shape, like it's happened to a lot of the hardware companies, and also you have new companies that emerge and become multi-billion-dollar companies, like I'm sure Terra and Quantinuum are going to be, but basically, and that's what happens, basically. So we're very excited as to where the cycle is right now, because I believe, honestly, that it's ripe, right at the moment where it is right now, because of everything that is going on. So sorry, I didn't mean to be so winded.
No, that was great. So thank you all for those comments. In the audience are many investors and industry experts who have heard about quantum and are learning about it, but probably aren't experts in it. How would you suggest that they get into quantum and take the first steps?
Yeah, well, very simply, if there are governments or armies and they need to really secure their exchange of information, they have to think quantum, and quantum key distribution. It's a way to secure using existing networks, existing fiber optics to secure an exchange of information without having to invent cryptography or a very complex mathematical problem to secure the exchange. It's just by construction, by DNA, it is secured. So that's the first thing. If then, for any institutions, industrials that have complex problems to solve and which are not solvable using classic supercomputers, what do they have to try to optimize those problems? They have deep machine learning. Okay, that's a solution. It's not a rigorous way to find the solution, but it works. Problem, it means you have to use thousands of GPUs, cost a fortune, and use a lot of energy. If you use a quantum computer with the hardware of existing firms, including Pascal, Candela, or maybe and some other in which we have invested, but that's another story. You can have the same level of solution. Okay, it's with even 20, 50, 100 qubits, and you have the same level of solution of good solutions than the best method of deep machine learning, but you use much less energy, and it costs much less. So in fact, quantum advantage is already there at the moment. And now, if the hardware progress and can gather thousands of qubits and with good quality, then you can solve the problems that even the best deep machine learning AI methods cannot solve at the moment. So it's really the message to all industries, people serious about the future, is just to gather a team to begin to train people about quantum algorithmy, about quantum hardware, and just make the proof of concept and invest, because in 5-10 years, well, it will be too late. And the ones that will have taken that steps will have a huge competitive advantage.
Exactly. Yeah, the companies that will most benefit have already started.
Exactly.
Marcus?
Well, yeah, I would pick the stakeholders up with the following. I think we all had our ChatGPT moment, right? An inflection point, something was developed kind of hidden, and then all of a sudden the technology is there and, is mind-blowing. And I think you can expect the next thing, coming up with quantum AI. I mean, if you are excited about Gen AI, generative AI, and large language models, I think you should be really, really excited about AI on a quantum machine. Why is that? First, you have the exponential speed up, right? But then also the underlying quantum physics, at least in its single event character, is non-deterministic. It's non-causal, non-local, but it's non-deterministic. Classical AI is more or less, these are stochastic parrots, right? They are deterministic, nothing really creative and intelligent. With quantum AI, we might open that door for something, a technology, which shows the potential of being creative because you have the quantum randomness coming in, something which you cannot predict in a deterministic way. So therefore, I'm very excited about quantum AI, and I think that will be the next kind of big kind of ChatGPT moment.
Manny?
I agree with Marcus, by the way, about quantum AI. We have invested in AI, I've learned a lot about AI. And AI today, AI cannot feel, doesn't have emotions. It's very, very convenient, and obviously it's changed significantly. And I mean, if I was a coder or software developer, I'd be afraid about my job even today, right? Because basically that verbal command to AI, and you have a bot instructing another bot, all this is great. But I agree with Marcus about, the ability, the moment you put that with quantum, like you were talking, Marcus, you have a real brain that is random, and then you create. That's the danger moment. that's the exciting moment that when that happens. As far as how do you learn about quantum, listen, I'm sorry, I'm very rudimentary in the sense of that. So I really started just by consuming everything that I could around me. I have a very smart team of people that know a lot about this stuff, so I spend a lot of hours with them having patience with me and tutoring. Now it's easier. Honestly, over the last few, even just the last year, there's so much content out there that is easy to digest without having to have a headache after digesting it. I have a friend, his name, he goes by Worley, but his name is Will Hurley. He just recently wrote a book, co-authored a book called Quantum for Dummies. I would strongly recommend it. I mean, basically, even Quantum for Dummies is difficult to understand. So you start there, and then when you begin absorbing, it kind of begins making, you have this aha moment. You don't know exactly how it works. You say, I get it. I understand. I'm not sure that we're going to be teleporting. If you remember Star Trek, Beam Me Up, Scotty, I think it's going to be a few years before that happens. But you understand the practical aspect of what's happening right now, right this second. So I was very excited when I learned a lot more about the products that Marcus is putting together, because basically they are now products. And just another proof, another point to this readiness is right here at the conference, I was talking to the CEO of Accenture, and Accenture has 765,000 consultants around the world, and she actually already has a quantum hit force that basically they're going to all their major customers and government customers. Quantum is being mandated already. In May of 22, there's National Security Memo number 10, specifically already talks about NIST and the new encryption key and how you have to change and get prepared. The federal government in the US, big banks, a lot of our customers in our cyber company, our very largest companies in the world, they're all getting cyber prepared. So basically, they're actually excited about the combination of both. So I think the time is now. By the way, I never answer what I think is besides the artificial intelligence and creating that aha moment sometime in the future. I honestly believe that eventually, as dangerous as quantum is for cyber, eventually, coming up with the, deciphering the encryption key of RSA, of the current encryptions that will be happening relatively soon, in 3 to 5 years. All of that is very dangerous, right, basically. But on the other hand, on the positive side, I believe when you take together this random number generation, you take the quantum key distribution, you take, the quantum networking. From a networking point of view, it's actually fascinating because eventually you create a quantum internet. So I believe that the whole cybersecurity issue, it's not going to be soon, so don't be so fast in selling stock in your your cybersecurity companies, but I believe eventually cybersecurity is not going to be an issue because quantum is actually going to resolve it. Yep. And I know for me, having been I've always made the statement, this is never going to go away. As I've learned about quantum, I am now convinced that cybersecurity in the future will not be an issue, basically, because it will be impossible for you to be able to eavesdrop the way that quantum works.
Good. Good.
If I quickly may add,
yeah,
I totally agree. I mean, a completely quantum secured protocol, and we have them, we will have them, we'll implement them. By the way, we do so already today with clients. This is the final end game on cybersecurity, right? As long as the laws of the universe don't change, kind of a real quantum encrypted protocol is ultra safe, right? It will not be hacked, even not by the fastest quantum computer. So therefore, it is kind of, I think we will have the solution to secure ultimate privacy in the quantum age.
100%, very exciting.
I'm very glad you mentioned that, because there's been a lot of attention given to the fact that about 30 years ago, this very smart professor named Peter Shor figured out the algorithm for how a quantum computer could hack a lot of types of encryption. And 30 years ago, this wasn't such an issue because there were no quantum computers to speak of. But today, this is becoming a real issue. So you've probably seen a lot of headlines about how quantum can produce hacking. What receives less attention is how quantum technologies can be used to protect against hacking. And so I'm glad to see that you mentioned that we can use these technologies for good things as well. So, I think we have just a few minutes left. I wanted to open it up to questions. Brent, I saw your hand first. Yeah?
Thank you, Mark. And thank you, gentlemen, all for coming. It's great to have you here in Saudi Arabia. I just have two questions which are quite tightly interwoven, perhaps to dispel or confirm a myth which Marcus has specifically spoken to. I guess in terms of quantum computing, make blockchain obsolete in the sense that it can unencrypt all of that? And secondly, when you think of store now, delete later, does that mean that everything that we've created up until now will at one point become completely transparent?
Yeah, if I may answer, great questions. Start with the second one. Yes, I mean, if you think you have time to migrate to quantum secure communication protocols because the hardware, the quantum hardware isn't yet there, which will be able to hack you, I must tell you there are a lot of malicious actors out there who try to harvest any classical encrypted data which they can get. They store it to decipher it on a future quantum machine. Therefore, you have to act now. If you are quantum vulnerable and you have confidential data, you should better migrate to a quantum secure standard now. Otherwise, you are vulnerable already today. And the second thing is, yes, I mean, we did leading work in analyzing the quantum threat and also analyzing the hash function. We could show that, regardless of symmetric or asymmetric encryption, there is no quantum safe cryptocurrency protocol. All these existing protocols are not quantum safe. So what will happen if they would not change? Yes, all those crypto digital assets would be hacked with a future quantum machine. We are not yet there, right? You need much more powerful machines, but ultimately this would happen if not those crypto protocols also migrate to a quantum secure standard, and they have to do that. And I think if I observe the blockchain community, I personally think they do not yet take that challenge seriously enough, actually.
Yeah. By the way, I just want to add on your question about the buy now, decrypt later, etc. We have an elite team of hackers that we employ that spend all their lives on the dark web. And one of the things that they measure is the type of data that you can buy and the prices of it, right, basically. And I can tell you, we have had, over the last 6 months to a year, the amount of encrypted data for sale has mushroomed, and the prices have dropped significantly. And what happens is that sooner or later, look, all of this encrypted data is valuable, whether it's now or 5 years. If you have the plans of a nuclear plant, or if you are a bad actor, or something like that, and you're going to eventually, so meaning is that everybody's beginning to think that it's going to be done, and that's happening as we speak right now on a very vivid marketplace down there.
So if you want to buy hacked encrypted data, you can talk to Manny.
And I have a special FII discount if you want.
Shema, did I see your hand earlier? No. Oh, I see.
Thank you, gentlemen, for nice conversation. I have a question on challenges. So the challenge which you, Marcus, I think, has mentioned, like about the hardware. And currently, since I am a semiconductor device engineer, so I am working on the cryoelectronics perspective for the quantum technologies. And currently, people are working in especially the integration of silicon cryoelectronics with silicon quantum dots, quantum dots for quantum technology. And another point is people are going for photonics quantum technology. So my question is, what is in your in your opinion, what is the ultimate solution? What do you think for making this, technology to help everyone?
If we knew. No, at the moment, no one knows the answer to that question, and so there are indeed several hardware technologies for quantum computing, so photonic, silicon, superconducting.
Each with
materials,
advantages and disadvantages.
neutral atoms,
There's no obvious winner.
ions, like 5 or 6 minimum different hardware possibilities. Each have advantages, qualities, and scaling. So it's too early to say. Yeah, we are like in the big, IT industry in 1953. So, but it's going very fast. So we'll see. It's also a lot application driven. So if you are an industrial, you have a specific optimization to make to solve a problem. You can initiate a dialogue with a certain hardware technology, and you will find a solution, and maybe another industrial with another technology. So we are really at the beginning. It's not too early, as Manuel said, but it's certainly not too late and you have to look at those technologies very carefully.
So unfortunately, I think we're out of time. So I'd like to thank the panel here
Mark.
for your comments. And we'll be around, of course, to answer any questions.
Thank you.
Thank you.